Making simple solutions is hard, especially if you're the one implementing it. Yesterday, I found a good question to ask oneself, and this helps us to stop over-engineering. If you work with a developer, this will also help you guide technical discussions and make simpler and cheaper solutions. So the background here is that yesterday I talked with one of my developers who was building an MVP, and we had an existing database design. This developer wanted to change a small thing and change the database model a bit. And in the end, through applying this question, we found a way that we actually didn't need to change this at all. And the thing I want to teach here is the solution is always bigger than the problem, and we're going to get to this in a bit. But first, why is this actually relevant? The problem is that we are always, like, engineers are drawn to engineering. So the principle of the guy with the hammer, for the guy with the hammer, everything looks like a nail. And so especially engineers like to build more beautiful stuff, they like to abstract more things, and then what ends up happening is that there are often things that never make it into production. And just a couple of examples. So for example, an abstraction that is only used once, or some fancy UI that's only exactly used by one person somewhere in the back end, or a database table that doesn't add any benefit, and this is our case here. What I'm pledging here is that we need to focus more on SHIP and keep solutions simple. And I want to quickly talk about this database design. So I don't have an example here because it's not really relevant, but basically what he wanted to add, we had a table called agents, and he wanted to add a table called subscriptions because he thought it actually makes sense in the natural language sense that an agent has subscriptions to do certain things. And he had some good arguments that this whole thing would be more natural, would be cleaner and nicer to look at. But then I came across this one question, and I asked him, so we have a design that already works, right? And I asked him, if we make this change, is there something that this change enable us to do that we couldn't do otherwise? And so the answer was no. And so that was the reason why we didn't change the design. So this question helped us guide this design decision. And I wanted to quickly explain why this is important. So imagine we have a certain problem here. This is our problem in red. And usually when you build a solution for this problem in terms of like a machine that solves this problem, the machine always is more complex than the problem. So it's just not possible to build a machine that's like this. It won't solve at all the problem. It's just not possible. It's a law of nature. So any kind of machine that solves a problem needs to be bigger than the problem. And some overhead, because especially in software, you need to have some, even if it's just a deployment cycle, then you would have something that's just a bit more complicated. So let's add that here. Okay, now, so this is our solution. And if something would get added in our database example right now, the solution would be more difficult. So the solution would actually be more complicated than the initial solution. So let's say this is the thing that worked already, and now my developer wanted to expand it and add another database table. So what we would now have is the existing problem, which still gets solved, and then something on top of that, which is just called pointless over engineering, because it's Yagni. Yagni, you ain't gonna need it. So this would not expand the problem space. It would not add value. This law of nature means that a solution is always more difficult than the problem, but the inverse also is true, which means if a design suffices a certain problem, there is no point in making the solution more complex. Let me know if you agree with that, and leave a comment on Twitter or on YouTube.